Thank you for joining this IFAC Industry Connect webinar, which is part of a series organized by the IFAC Industry Committee with the aim of increasing engagement in IFAC activities and enhancing the value of IFAC to industry. IFAC is the International Federation of Automatic Control, which is a multinational organization focused on control engineering, research, and the impact of control technology on society. My name is Bill Tubbs, and I'll be the moderator for this panel discussion today. I'll first do a brief introduction to the topic, and then I'll introduce the four panelists who will be sharing their insights and experiences. Just so you know, everybody on the line, you should be muted. And so if you want to ask questions or if you have any questions, just put them in the chat on the Zoom. And we'll try to answer some of the questions at the end if we have time. The idea behind this webinar was to focus on the management and organizational aspects of process control engineering and process optimization at a site level. We've had a few webinars on related topics, which you can find on our YouTube channel. Some of those focused on how improved control performance monitoring can bring performance improvements and economic value. Today, though, we're going to be focusing not on the control theory or the technical solutions. We want to ask, have these been successfully implemented? Have they delivered the intended benefits? Are the benefits sustainable? And if not, why not? What is it that we're doing or not doing at a site level to get the full potential benefits? So roughly speaking, that's the plan. I'll now introduce the four panelists. So firstly, Dirk Baas is Principal Advisor Process Control at Rio Tinto based in Brisbane. He began his career as an instrument technician and has been working in instrumentation and control for over 30 years. In the last 20 years, he worked in a wide range of industries, including food and beverages, manufacturing, and mineral processing. In his current role at Rio Tinto, he works with operations to identify opportunities in the processing plant where they're limiting the value chain. Dirk believes good automated control is the most cost-effective way to make sure the plant runs as close as possible to its maximum capacity. Secondly, Ramesh is Senior Automation and Controls Engineer at Sinopec, Canada. Ramesh's industrial experience spans oil and gas, energy, mining, and metal sectors. He has worked in multiple technical and leadership roles, where he has acquired extensive expertise in all layers of industrial automation and controls, advanced process control, OT cybersecurity, and advanced data analytics. He successfully led and delivered numerous projects that were first of their kind and received internal awards, patents, and recognition for his many contributions. He recently joined Sinopec Canada, based in Calgary. Sabine Pegel is Plant Manager and Digitalization Specialist at Covestro Chemicals in Germany. She is a chemical engineer by training, specialized in plant management and production, organizational change management, process optimization, and digitalization. After doing a PhD at the University of Dortmund, she gained extensive experience in multiple technical and leadership roles at Bayer and led the global process optimization group there. For more than 14 years now, she has managed various production plants at home and abroad for Bayer and now Covestro, always focused on how digitalization and process optimization can be implemented sustainably in production. And finally, Eduardo Nunez is VP of Process Optimization at Molycop, based in Kamloops, Canada. He obtained his master's degree in process control at Laval University in 2005. His passion is operational excellence in real time through automation, process control, and optimization to achieve safer, environmentally friendly, and profitable operations. He has been designing, implementing, and sustaining process control solutions from basic regulatory controls to advanced solutions in mineral processing plants for more than 20 years. He specializes in instrumentation, soft sensors, DCS, HMI, data historization, alarm management, OT, modeling and simulation, data analytics, and machine learning. His main contribution to industry is developing and showcasing the benefits of a culture of process control and optimization. He's been recognized by the Canadian Institute of Mining and is an author of papers published in international conferences and journals. Welcome all four of the panelists. Thank you for joining today. So now I'll introduce the topic and get the discussion started. So if you look in the academic literature, a number of surveys have been conducted over the years. In 2002, for example, Desborough and Miller found that of the 26,000 PID controllers they surveyed, only 1/3 were classified as delivering acceptable performance, and almost 30% were found to be in open loop, meaning they were effectively switched off. When it comes to advanced process control, and by that I mean, for example, MPC, Model Predictive Control, and RTO, which stands for real-time optimization, these are much more difficult to maintain, and sustaining the benefits is particularly challenging. Darby and Nicolau wrote an assessment of RTO practice in 2011 and found a split in the industry. Some companies are convinced of the benefits and continue to invest in this technology. Others have concluded that RTO, as it was implemented at the time, is not viable for them. So that brings us to the questions for today. Is the situation as bad as these surveys suggest? And if not, given the benefits of process control, why does this state of affairs persist? Or what strategies and best practices exist to maintain and sustain reliable, profitable process control? So to kick off the discussion and to guide it, I would like to offer this model, which I'll keep on the screen here. It's a simple model from organizational effectiveness theory called the 5-box model, appropriately. It's a high-level model of what is needed in an organization to ensure that you deliver measurable, sustainable results, which is the box on the right. And the model says that to make results sustainable, behaviors need to change. In other words, throughout the organization, people need to be doing things the right way consistently. And to achieve behavior change, 3 things are needed. Firstly, good management and management practices. For example, leaders in the organization review the right performance metrics. People are in meetings when important decisions are made, and they direct resources to the top priorities. Secondly, you need to have good work processes or effective processes to ensure that people work in a way that solves problems and prevents them reoccurring. And thirdly, you need the right skills, knowledge, and training. Basically, the right people with the right training to do the job. Now, that's just a model. You could add technology to this list, of course, which is an important enabler. But for this webinar, I think we want to focus on these organizational and behavioral aspects of getting results for process control. So I'll kick off the discussion, and each participant each panelist rather, feel free to respond. I know you all have lots of thoughts and ideas on these topics. And I'll start with the question I mentioned earlier. So today, is the current state of plant process control really as bad as some of those older surveys suggest? Who would like to answer that question first? I guess, Sabine, do you have audio is the question? If not, does someone else want to step in?
I'll start. I feel that the state of process control is bad. And the primary reason is there isn't really a discipline or engineering discipline for process control. So process control engineers They're either a chemical engineer who's learned how to work on a control system, or an electrical engineer, control system engineer who's learned how process dynamics work and then has pieced together how to do process control. So yeah, and then the next thing is nobody knows where to put process control. Is it a maintenance function? Is it an operations function? So process control doesn't really get looked after that well in most industries. And so that leads to, because there's no little place where we really live, the skills aren't that great. And then what I've noticed in a lot of functional specifications, they loosely describe how the process should be controlled. And when you look at it and it's not being controlled, you read the functional description and you say, yep, that's probably a way to interpret how the guy could have implemented it, or the person would implement it. And so the control system doesn't really deliver what it was intended to do. And therefore, after that commission, it's not working that well, and everybody just accepts that it's not working as well as it could. Yep, and that's my thoughts.
Yeah, thanks, Dirk. I mean, there's a couple of things to unpack there, which I encourage us all and you to do. I mean, I heard things about skills and knowledge there, and perhaps processes and management as well. Do any of the other panelists want to chip in and add to anything Dirk said, or present your own experiences?
Yeah, I can offer. Oh, Ramesh, go ahead. Go ahead, Ramesh.
Go ahead. Generally, process control is kind of seen as a black box sometimes, and that affects the sustainment and maintaining process control assets, right? People don't understand how they work, so when people move or people change, Eduardo is a great example. When we work together at Tech. So as people move around, the management sometimes does not know, kind of the right people, the right team, the right size of the team to sustain these applications. I have seen, at least in Western Canadian, oil and gas, it hurt process control when, does it take 2 process control engineers or 10? Management has no idea. So that hurts the sustainment and maintenance sometimes.
Great. So changes, do you mean changes in the plant or changes in personnel, or both?
Changes in personnel. Sometimes it's the markets go through these cycles. So our commodity prices go through cycles, and during those fluctuations, that affects how many process control engineers can you hire to sustain applications.
Right. Yeah, there's people have mentioned the skills shortage, and I'm sure we'll come to that. I'm guessing, Sabine, we've still got a problem with your audio because I haven't heard anything from you. Hannah, do you know if that can be solved? Hannah is, sorry, I should have introduced Hannah as our assistant here with the Zoom meeting.
Hi, I actually emailed Sabine. She said she had to leave the meeting because of her audio issues, and we're trying to get it resolved. But is there any way you can check the participants, like where they're joining? Because I think there's some in the waiting room that you have to admit.
Oh, do I? Okay.
Yeah.
How do I do that?
So you should be able to click participants at the bottom, and then if there's anybody who's waiting, it'll just say admit and a blue button next to them. If you see no one, there might be no one. She might not have joined yet, but I did tell her to restart her computer and try again.
Okay. Yeah, normally that pops up as on my screen. Oh, it says at the top there. Here we are. 3 people waiting. All right. But yeah, there's Sabine. All right. I didn't see that.
Okay. We'll see if her audio works.
Yeah, she just says joining now. Sabine, can you hear us, or can we hear you now? That's the question, I guess. And I guess the answer is no.
Can you click on her name and click unmute, request unmute, just to see if it'll work?
Ask to unmute. Yeah, I'm clicking on that.
Okay, because before she didn't have that microphone icon, so something is better.
Yeah, okay. Well, that's a shame. That is a shame, but never mind. We'll just carry on with the three of us. I mean, hopefully she'll figure that out, but I don't know what else we can do at the moment. We better keep going.
Hello, everybody. Can you hear me, Sabine?
Oh,
here?
yes. Yeah, fantastic.
Okay, now you accepted my participation. That's good. Thanks.
Well, thank you. Thank goodness for that, Sabine. Thank you. I'm glad you're here. Sorry, everybody, about the problem there. But that's good timing because we just asked the first question. I don't know if you heard the answers.
No.
But Eduardo and Ramesh and Dirk both commented. But what's your experience in terms of the state of process control today, now that we've got you on the line?
Okay, good. I have to start immediately. Yeah, I have really good experiences. If you're talking about control, performance, and metrics, in some cases, in smaller productions, well, we might face some troubles, but overall, we made at Covestro tremendous progress within the last years. So today, a lot of production plants are controlled very well, and we were able to achieve benefits, energy integration, sustainability targets, and so on such a high level, and mainly enabled by good control concepts and digitalization. So, yeah, we have some plants where we have troubles, let's say it this way. But on the other hand, we have a lot of plants and production units which are running with the help of APC, and they are not switched off or anything else. No? So, yeah.
Okay, that sounds like a very good story. And I'd like to delve into how you've achieved that, some of the reasons perhaps, why you've achieved that success. I mean, maybe you could touch on them briefly now, but certainly during the webinar, you know, what have you done from a management point of view? Or what have you done with processes and procedures or training? Can you give us a hint now as to how you've achieved that?
Yeah, of course, it was a long way. No? Speaking frankly, it was a very, very long way. And at the end, it's all about people. So you have to convince the people in production and show them the benefits of it. What can they gain if they are using APC control, PID controllers, alarm management, and so on. So if you are getting the buy-in of the people in the control room, they keep it running.
Okay, well, that's a great segue to my next question. So I'll ask it now. What are the benefits of process control, and how does poor process control impact the business? Anybody step in and answer that?
Okay, I'll open the bathroom again. Yeah, in my opinion, process control is the cheapest and way of improving the revenue of an operation. You get benefits that just are untapped and they're just sitting there almost for free. But you know, to realize these benefits, you have to ensure that the whole process control pyramid is in place. So that means your instruments at the bottom layer that are sensing the process are all working. Then your regulatory control loops are working. Your advanced control loops with feed forwards, dead time compensations, just to make the plant stable. Once you've got your plant stable, then you can start putting the really clever stuff that will push you that extra little bit. And yeah, you almost get those extra benefits for free. Normally it doesn't cost you any more power, uses less reagents, and you get probably better recoveries.
Okay, so you're probably preaching to the converted here. We're all on board with those ideas, and we believe in process control. But does everybody else in the organization, or how do you convince other people, in particular management, for example, what the benefits are? Dirk or Ramesh or Eduardo?
I can offer my perspective. I agree with Dirk just mentioned. I believe process control also opens the opportunity to achieve real-time optimization that everyone wants to achieve, and offers you the technology and methodology to do that. Starting from measuring the process, because if we can measure the process, we can control it. And if we can control it, we can optimize it. I think process control allows you to do all that in a methodological way, in a systematic way, instead of just going to what everyone wants to do these days, is just AI without even having a solid foundation of having a good instrumentation. And that is the challenge, right? So process control, if we follow the process control hierarchy, we have a specific way how to start with a good process, good instrumentation, a good DCS, a communication network, basic PIDs, HMIs, historian, and all that to go to the real-time optimization that everyone wants to do, right? Like these days, you cannot even buy a washer machine without AI these days. So everyone wants to do AI, but then how do we achieve that? Is through process control and following that process control hierarchy.
Absolutely.
Absolutely. Absolutely. 100% what Eduardo is saying. A poorly maintained process control, you can really correlate with more unplanned shutdowns, operators making rate cuts, off-spec barrels, environmental incidents, safety incidents. The poorer the process control is maintained, these type of abnormal situations increase. A really well-maintained process control actually directly impacts the rates, throughput rates, product specs, environmental performance, safety performance. There's a direct link between the two.
Excellent. Okay, so that seems obvious then, the benefits of process control. Let's dig into perhaps the next level of detail. Is there anyone who'd like to share their experience at a site where process control was not satisfactory, and perhaps get into some of the reasons why? I know that's a difficult topic, so let's not mention names, or let's just focus on the issues. But if someone can share that some real experience, that would be great.
I can step in, yeah. So of course I have made a lot of positive experiences and a lot of plants where it's very good running. But of course, first of all, if you are implementing concepts which are not accepted by production, by the plants, then you can have difficulties. That's one point which could really deteriorate your control system. And on the other hand, of course, all the concepts have to be maintainable. So you have to have people on site who are able to maintain all your concepts and retune your controllers and teach all the concepts, things like that. So there we had some bad experiences as well, of course. Yeah. Yeah.
And can you say what the cause of that is? Was it staff turnover, or had they been in a good state in the past and deteriorated? Is there anything we can learn from that?
Yeah, I think it is a change management in the organization. So if I started implementing APC concept or base regulatory control concepts around about 20 years ago, even a feed-forward controller was too complex for a lot of people, and it was not accepted. Today, we are working with AI, we are working with model predictive control, and people have trust, people are believing in it, and people are at least understanding that it could be beneficially. So it is a change management in your organization. It's not this nerdy stuff from some PCT or APC engineers. It's something what is more and more accepted in chemical production units.
Great.
Yeah.
Anyone else want to comment?
I've seen some control loops that used to work really, really well, and they were very effective. And then people decide that, you know, we need to make a little change here and there and improve it a bit. But because they don't understand the process dynamics or the way the process control is working at the moment, they put something in which starts to mess it up. And before you know, you've suddenly reduced the control. And that's not because they intended to mess it up. It's just because they don't have the deeper understanding of transfer functions and how to put process control solutions together properly. But I think, you know, maybe I'm talking in the mining industry, in the chemical processing industry, where Sabine is. I'm sure they're doing a lot better than we are in mining. But that's just my experience.
Mm.
And how do you address those kind of skill or knowledge issues? You know, we can't have people at every plant necessarily, and the plants in quite remote locations in the mining industry. How do we get the level of knowledge and skill up to the level we need to avoid that?
Oh, I wish I knew the answer for that, Bill. It's a really tough one. We do get a good control engineer, and you know things run really well. And then because he's in a remote area and he wants to be with his family, he packs up and leaves and moves to the city. And then yeah,
Right.
a couple of years later, we're back in trouble.
Interesting. So if I ask about management, it's management's job to identify issues when they occur. Let's talk about KPIs, so key performance indicators. What key performance indicator can management put in place to identify when trouble starts or a problem develops so that they can then address it? Does anybody have any experience with good KPIs for process control performance?
You know, the simplest KPI is the service factor. You know, even whether it's a simple PID or advanced process control, what percentage of the time, you know, the controller is in its preferred mode, you know, whether it's auto or cascade, or if it's an APC, is an on or off. That's the simplest KPI. And, you know, management should be looking at, you know, or setting some thresholds for that service factor. You know, it shall be above, you know, whatever that percentage might be. That's a simplest KPI.
So that's basically the percentage of control loops that are actually functioning in automatic mode, right? Simple as that.
Preferred mode. It could be automatic, it could be feed forward, cascade, on, off.
Yeah. And you call that the service factor?
That's right.
Fantastic. Anybody else have experience with KPIs they'd like to share?
Yeah, I totally agree.
Eduardo.
Go ahead, Sabine. Go ahead, Sabine.
I think in general, control concepts could contribute to all KPIs relevant in production. So to all balanced scorecard KPIs like energy efficiency, general efficiency, quality, capacity, and so on. So for the team and for the people in production plant, you should make a business case. What would you like to achieve? What would be the additional benefit by implementing control concepts and APC concepts? And what we were talking about, statistic of controllers in manual mode or open or cascades, I think this is more, gives a deeper insight for the control engineers, for the PCT engineers. And if they figure out that people are, for example, just opening cascades or taking control concepts in manual mode, then it's a very, very strong indicator that you have to talk to the people, that you have to do once again a training, that you have to teach it, that you have to understand why it is put it in manual mode and not accepted. That the APC concept could be beneficially to this production unit. It's a lot of workload. It's a lot of talking, discussion. Yeah, of course. No?
Yeah, so linking it to actual production KPIs, I heard you say. Eduardo, you had something to say.
Yeah, basically, I totally agree with we said, especially with the service factor or utilization, the only thing that I would like to add is that in my experiences, like it has to be over 90%. Because once it drops the 90%, it drops to 17, drops to 0 very fast. So it's very important to push it to 90% or more. And the other thing is that I would like to add is that it's not only for the management. I believe that it's also important for the operator, that the operator wants to achieve that high utilization. So how do we, as a control engineers or control specialists or automation specialists, how do we not only push that to the management, but how do we engage the operator to try to use the controllers at that high level? Because by the time that it gets to the management, it's already sometimes too late. It has to be real time. We're talking in real time, so then that will be my other thing. Then the other thing that I could add is sometimes we also have to check the utilization, because it's in utilization, but in saturation. So it's not controlling, it's already pushing to the limits. So it's kind of a fake utilization. So then I think it's the combination of the service factor with not being in saturation. So the valve is in auto, but it's already at 100%. The valve has to be within the limits, right?
Right.
When I managed a small control group, one of our KPIs was, and it was just to understand what was happening in the plant, was how many times did the operator have to intervene on a loop, changing the set point or something. And as soon as they were intervening a lot, there's probably something wrong. Maybe a valve was starting to get a bit funky, or a level sensor or something like that. So we'd go have a chat to them, and we would find we'd pick up a lot of things before they would eventuate, because that was sort of like a leading indicator. There's a bit of a problem.
Right, and I come from a background of machine reliability, so critical machines as a concept there. I'm sure there's a similar concept with process control. Is there? You list the critical process control loops, and you give those an even more high priority focus, right? Is that a concept? Critical process controls?
Yeah, for sure.
Yeah, sure. You definitely would monitor the critical ones a lot closer.
Okay, well, let's move on to work processes. So in terms of the way that work gets done, does anybody have experiences or insights of positive or best practices or issues there?
One thing I would mention is over the years, both ISA, International Society of Automation, and IEC developed a lot of standards around automation and process control. In one of my previous roles, we developed standards and best practices. Taking those ISA and IEC standards and kind of distilling them into your organizational specific standards and best practices, and making sure that in the change management process, you shall adhere to these, standards and best practices. That really helped in maintaining process control and automation assets at higher standards.
So you've had experience of doing that, of spreading those standards to the people.
Absolutely. Yeah.
Fantastic. Anyone else?
And of course, you have to think about ways of working. So if you have continuous improvement projects, for example, running and in place, and people would like to achieve better and better results, this helps as well to foster an environment where control concepts are accepted and people like to deal with it. So if you would like to improve, so there is an atmosphere of welcoming changes and welcoming complexer processes as well. And of course, if you're talking about work processes, of course, Lean Six Sigma could be one topic here to mention, ways of working. But of course, on the other hand, analyzing all the data and maintaining and troubleshooting, so keeping it alive. It's also really, really important that you always check if it's still running, is it still in place, to still achieve what you have implemented, review it on a regular basis, things like that.
Right. Okay, so continuing the same theme, I've got another slide here. So I just brainstormed from my experience, what are the main people in a process plant or the main roles? And I've just put them on the screen here. So these are all individuals. Back to what you were saying, Sabine, how do you get all these people working together when it comes to process engineering, process control? Who are the key people and how do you get them working as a team?
That's a tricky part, of course. It is a tricky part. And as for sure you introduced myself before I was able to attend this meeting. I was a PCT engineer before and an APC engineer, and then I switched my role to a plant manager. So one of the key is, of course, the plant manager itself. It should be top-down approach on one hand side. On the other hand, at my company, we are currently already working on autonomous production units. So if you would like to achieve autonomy, you need people and the whole team to discuss on eye level, let's say it this way. So the nerdy AI specialist has the same voice as our production expert or our operator, because the nerdy mathematic guys, they do not understand the production unit. On the other hand, the production people do not understand all the mathematics, but they don't have to. They have to find a way to work together with each other and to say stop and to rely on each other. And at the moment, if you have set up a team which has an environment of trust, then it starts working, and then they are improving and more and more. And this is what you have to achieve. That's my personal opinion, and that's my experiences over the whole plans we are having here in my company. And it is a lot of workload to do so, and you need a networking system, of course. You have to look where are the change agents, but you have to spread this team spirit, of course, over the whole production unit, 60, 100 production units worldwide.
Excellent. Well, that's challenging. So from the perspective of a control engineer, if I'm the control engineer, I'm thinking about organizational silos. I don't know if you're familiar with that concept, but, if I just sit in my office and wait for the phone to ring, obviously that's not the right way to work. What's the alternative? What should I be doing? Or what is the role of the control engineer? Is it just one person, or is it more than just one person? Can someone comment on how control engineers should be interacting with others?
I can offer a perspective on that. I just want to touch one more thing on what you have there on the screen, like especially the four at the bottom. It's kind of they're holding a table, right? So each one is a leg of that table. If one of them disappears, the table is going to fall. And the table is called operational excellence in real time. So if we want to achieve that operational excellence in real time, those four have to be working together like they work on a table. Like the four legs need to be supporting the whole thing. And obviously, if we want to do it in real time. Now, as Dirk mentioned at the beginning, what is a process control engineer? What is a control engineer? It's where does it come from? Is a chemical engineer? Is a technician? It's so in my experience, I think not a process control engineer can be divided, and it can be divided in three things. One is the integrator that support the base of the process control hierarchy. So it's a guy with that's all the configuration, the PLC, the HMI, typically the Historia, configures controllers, the controllers based on a controller strategy that is defined. So it's basically more a programmer that has that. But on top of that, we need to have the control engineer that has more the education in control theory, basically, and not only knows control, but also knows the process to be able to do process control. It's very different to have a pure control engineer than having a process control engineer that takes in consideration the process to be able to do control. So this is the kind of person that designs the control strategies, fine-tunes based on modeling, but uses whatever technology we need to use. Like if it needs PID, use PID. If it needs MPC, uses MPC. If it needs neural networks, that's what it's going to use, right? And then the other one that is typically the one that is a chemical engineer or some kind of a process engineer that is put in process control is the role of facilitator, being able to promote process control to management and to operators too. So then what I'm trying to say is that process control, that engineer is a role that is divided in three: in the integrator that does the programming, the integrating process, the control engineer that basically designs the strategies, and the facilitators that promotes. And then with that combination, in my experience, that when it's successful. If you have only the facilitator that doesn't have the basics, then it's going to fail. If you have someone that is able to do all the programming but doesn't know the process and is not able to promote this to management, it typically fails too.
That's very good. I like that concept, and I like the idea of the table with the 4 legs. Fantastic. Now, Ramesh, Dirk, do you want to add anything to this?
Yep. That special person Eduardo was talking about, they're very hard to find. And you'll normally find that they only have one or two of the 3. But you get very lucky if you've got somebody with all 3. And, you know, sometimes the site will have to have 2 people that will cover all 3 points, but then they don't have the budget to have all 3. So then you're going to have a little weakness. Yep.
Yeah, great. Okay. Well, thanks. Let's come to the third box then, the final box, which is skills or people and training. And I've heard a lot about skills shortages and, you know, aging workforce and, you know, young engineers getting attracted to other industries. How can companies acquire, firstly, and maintain the skills and knowledge we need to design and maintain process control? Does anybody have any experience, good or bad, suggestions for that difficult problem?
It is, we are facing really a skilled labor shortage, and we are never ever we will have enough PCT engineers or process control engineers. I like what you said, Eduardo. And what we are doing currently is we are training people, we are training operators, we are training production experts to try to step in this gap a little bit. So if you have a network of people understanding more and more about what is needed, then you can free up resources for the really core topics. So that the process engineers is rare people we everybody is fighting for currently, that they really can focus on the more complex things. In the chemical industry, we also have sometimes APC academies, so people with a background and people who like to do things like that and have a little bit of dynamic understanding or modeling understanding can learn a little bit. So we train them by ourselves as well. And we have programs in place that you can learn some smaller parts of it, let's say it this way, how to do so and how to help and support this overall topic. And last but not least, one idea we are focusing here in chemical industry is to use AI to overcome some of the parts of the skilled labor shortages as well. So in practice, what I have seen is, as I started as a young APC engineer, process engineer at Bayer, I met a lot of topics or moderations or logical sequential function charts. Today, in my production unit, my production expert or even my operator is able and capable to do. So
that's an internal training program at your company?
Yeah.
Wow. Okay.
So one thing from my, some of my previous roles as a process control manager that I noticed is it takes 3 to 5 times more training budget to train a green hat process control engineer versus like a process or a reliability engineer, because if you have depending on the systems you have, whether you have Emerson or Honeywell or Rockwell, and depending on the APC technologies, sometimes you have to train a green hat on multiple vendor specific training programs. So before even hiring, I used to attach a certain budget for the training, just for the training. And it's usually higher than any other EIT, that we used to hire. But, that's required because you can, you could come with a PhD in process control, but if you don't know how to use Honeywell, you're stuck.
Absolutely.
Yeah.
Right.
Yeah.
So there's a big hurdle there in terms of the training, the learning curve.
Yeah, and one other thing I would like to plug is, in Canada, for example, McMaster and University of Alberta both offer specialized, process control specialization within chemical engineering. I wish to see more universities do that. Yeah.
Yeah, that sounds great.
Yeah, the skill shortage is an interesting one. So I'm speaking of some remote mines that I've worked at in Laos and in Mongolia. Whoops, sorry, my cat just jumped up. Okay, so what we found is to get skilled people who have got a lot of experience in process control was impossible, that they were going to stay there for a long time and they wanted to earn an absolute fortune. So in Laos, what we decided, we actually grabbed a whole lot of guys from who'd got a degree in Laos, and he said, right, we're going to train these guys. And it worked really well because they were happy to be working in their country. There's not a lot of job opportunities there, so they were really happy. And we found they actually stayed in the company for a long time. And the same has happened in Mongolia. So I think sometimes we need to give some people who haven't got the top-notch sort of academic results and all that, give them a go, because the pool's only this big. If you limit ourselves just to the top people, we're making the pool even smaller. So yeah, maybe try that sort of approach. I'm not too sure. But because we had success in Laos and using the people, they were probably very clever. Not the greatest university around, but they turned out to be very successful.
If you back them up.
Yeah,
so
we backed them up. Yeah.
We just got time for one quick discussion here. We want to leave some time for audience questions. So specifically on APC, so advanced process control, these are the more sophisticated and difficult to maintain systems. I've got this in the literature. I found this this graphic here by Tom Badwell, who many of you probably know, but it is said to be the kind of process that you need to put in place to implement APC, and you need all parts, all steps of this process on the screen here. So does anyone have experience with implementing APC? And did they have a similar process to this? What works, what doesn't? What parts of the process tend to break down, and why? Can someone share an experience of APC?
I can answer if nobody would like to. I have some long-time experiences in doing so, and I had the chance to roll out APC concepts globally on similar production sites. So it's a very good graphic what we are showing here, and a very good test. So what we made is we had one pilot plant on an isocyanate production unit, and we made we ran through each step you are showing here. No? And then, as it was beneficially, we showed it the management and the board and rolled it out globally via the community of the plant managers. So they were convinced, in the technology center, they were convinced And they decided we will roll it out in US, in Asia, in Brunsbüttel. It's a small German country, sorry for that. And it was really, really fascinating because then we had all these control configurations, and it was just then about how to implement it together with a team from Texas, or how to implement it with a team from Thailand or things like that. And this is really fascinating because technology was quite clear, and then it was all about people, and what is needed, where are the gaps to enable the teams to roll it out.
That's fantastic. It seems to me, Sabine, that your company has a very good process for rolling out initiatives, kind of top down, but it reaches everybody and sounds like it's quite successful. So if you need that in your company, contact Sabine. That's my recommendation. Okay. Well, I'm sorry if I'm cutting it short here, but I did want to leave some time for audience questions. So Hannah, have you been able to keep an eye on the chat? And could you select one or two questions? Let's start with one. And hopefully that person can unmute and say their question. If not, I can read it out and one or more of the panelists can respond.
Yes, so I was able to find a question. Do you want me to send it to you or read it?
You can read it out. That's fine.
Okay, the question is, why is there a set criteria that a process control engineer with a set of experience level will only be hired, say, more than 5 years? But as we know, skilled people are getting limited. So how will that gap be filled?
Interesting. And who was that question from? Can you say the name?
It tells me it's from Akash Shudhari.
Akash.
Yes.
Thank you. Who would like to respond?
I couldn't agree more. I remember when I graduated, I couldn't find a role. And I was thinking, geez, why are you complaining about skill shortage? I'm here. And
Right.
now I realize we're doing the same thing. And, it's silly to say you have to have 5 years experience, because some people have 1 year of experience 5 times over. Maybe somebody with 1 year experience is actually just as good.
Right.
We need to actually be a bit open our eyes to this. Yes.
Very good. Thank you. And does anyone else want to comment, or should we go to the next question? Okay, let's go to the next question. If you can pull another one out, Hannah.
It looks like there's only one other, and it's from Andre. He said, joint industry university initiatives to attract fresh or soon-to-be graduates that become academic background in chemical engineering and control. Should they learn the ropes of vendor specifics on site?
For sure, yes. It's a really, really good concept, and we have good experiences with it to already work with the students and with the PhD students and attract them to our company. And of course, I'm currently in Germany. We are already in a war for tier for talent. So with my old colleagues from my department, we are picking out all the good ones and try to attract them to our companies on one hand side. On the other hand side, it's a good way to with some master thesis or things like that, or with some examples or some smaller projects, that they get some flavor of what is needed in practice, and in the industry.
I think that's a great idea as well. Within Alberta, I'm only aware of one vendor that does that. But I think every process control automation vendor should do that.
Interesting. Would anyone else like to comment? If not, if there's no other questions in the chat, everybody online, please post a question. This is your last chance to get these 4 people in one place for a while. Do so. I have a question. If there isn't, is there any more questions, Hannah?
It looks like Akesh just added another question. He said,
okay.
Does anyone have experience developing models using any other techniques than step testing example, such as valves, curves-based models?
Yeah, of course. There are a lot of ideas how you can get some models out of it. No? It's a whole. There are a lot of models. No? You can do step tests. You can random bias signals. You can do some PRBS signals you can bring in. But of course, you can also develop models by applying machine learning, by AI. You can get models by physical modeling, that you really set up a model by simulation models, no? Like operator training simulation models or Aspen models. So you can do a lot of things to achieve a model, yeah. Analyze historical data.
Yeah, and also keep in mind that the simplest model is always best for process control.
Yeah.
Don't go after higher complexity. Try TSTF. Try simple things first.
Absolutely, yeah.
Very good.
Very true.
Okay, we have just a couple of minutes left here. So I'll ask a question. I hear people talking about process autonomy, which I think is the idea that we can develop processes and control systems that operate safely and optimally without any human input, or at least a minimal amount of human intervention compared to today's plants. That sounds very ambitious, given what we've discussed today, but it would solve the skills shortage problem in theory. How achievable is that? Does anybody have any thoughts on the future for that?
Well, I think we're slowly building that, right? Like, but improving the level of controls, going to more APCs, going more to real-time optimizations and all that. By default, we're building that in the future. I think that's what is happening. But the one thing is that that I see is that everyone wants to move that too fast without making sure that the foundation is ready. Even in the MPC that you show that is already in the screen, is the one piece that I will add to that is make sure that your regulatory control is solid to be able to move to that level.
Right.
Because without that, then this is going to fall sooner than later. And that's the piece. So then we're building, if we have a solid foundation, like to build a building, then you can go higher. It depends on the foundation. So then that will be the piece that I will advise, like make sure that the foundation is solid, then you are able to attract good people from the university, from industry. You're able to increase your utilizations. You're able to go higher in the hierarchy. You're able to achieve that, what you just mentioned.
Well, the irony is, to put that solid foundation in place and maintain it, you need people, right?
Yes.
Yeah, and you have, but you have a lot of people. You have operators, you have plant managers, and so on. So not
Okay.
that's not every time has to be a plant manager, no? And with a background at Covestro for more than 20 years of working on this topic, we are really actually working on this autonomy topic as well, and started the first pilots on it. Huh? So it is possible, it is achievable, but it is a lot of work. It's a lot of work, as Eduardo mentioned. So start with the basics, start with simple models, start with understanding the dynamics, with cross and autocorrelation. Dirk, thanks for posting it. Understanding what are the correlations, do you have multivariable systems, things like that, and really try to find the best basic control structure. And then step by step, you can add some CFCs, some SFCs, and go higher in the pyramid, and then check what is necessary to achieve autonomy.
Fantastic. So on that note, I'll bring that to an end. I'd like to thank the four panelists. So big round of applause. Thank you very much for your time preparing and telling us about these things. I have on the screen here the references. If anyone's interested, I recommend giving them a read, although they are a bit outdated now, these surveys of the state of process control. And before I finish, I want to highlight the next webinar, which is actually coming up next week on Tuesday, on a different topic, making the leap from academia to entrepreneurship. And this is my colleague Atanas Sebazov, who will be talking to two startup founders, or 2 companies, there's going to be three founders present, about their journey making this difficult transition from academia, where everything's structured, there's a clear hierarchy, and you're talking mostly about theoretical things, into the real world of entrepreneurship, which from what I can tell is very messy, and you have to take risks and you have to solve practical problems. And so if you're interested in that topic, go to our website. You should find the links there to register. And finally, thank you to the audience for joining us today. It wasn't the best time zone for everyone, I know. I really appreciate you joining. And the session was recorded, and we'll be putting the recording on the YouTube channel at the end. So again, thanks to the panelists, and thanks to everyone who joined.
Thanks, everybody.
Thank you, everyone.
Thank you. Bye.
Thank you.
Take care.
Thank you. Bye-bye. Good work.
Bye-bye.
Bye.
Thank you very much.